Okay, so let's talk about, now, it's not like a proper classification, but so as a matter of fact, the lab that we did last time was mainly aimed at those digestive pathogens. The group that is called Enterobacteriaceae. It's a really long name. And we're going to talk about Commensal Enterobacteriaceae. Okay? You understand the term commensal, meaning that they can be found in the human gut. They usually don't harm humans. We don't really benefit from them, but they still can hang out there. So that includes Enterobacter aerogenes, Serratia marcescens, Proteus mirabilis, Klebsiella pneumonia, and Escherichia coli. E. coli. Put it right at the bottom. So, aerogenes. Okay, we good? They have a lot of features in common. So first of all, what do they cause? This to cause pneumonia. Why? Because lungs are sterile. There is no competition. Does that make sense? Good? Now what about these two? UTI, Klebsiella causes UTI readily as well. Make sense? Moving on. On top of that, Serratia loves to cause wound infections. So now if you look at this list right here, this four, they all like to infect some sterile sites. You see? Lungs, urinary tract, lungs, connective tissue. Are we clear? So in most cases, they aren't doing particularly hot in the environments when there's competition. Good? What about E. coli? Well, first and foremost, diarrhea. And UTI. As a matter of fact, E. coli is the leading agent, leading pathogen that causes urinary tract infection, which makes sense because it's so prevalent in feces and cross-contamination, transfer of fecal microbiome on the urethral orifice. That's what UTI is. Does that make sense? Now what about this diarrheal disease? So E. coli has different strains that I have on the table, like enteroaggregative E. coli, enteropathogenic E. coli, enterotoxigenic E. coli. They all cause diarrhea of different severity, but it's still diarrhea. Does that make sense? There is one strain, I don't remember, it's like 07H157, whatever. I have the, don't memorize this name. It's called enterohemorrhagic E. coli, EHEC. So this particular strain of E. coli causes dysentery, which is bloody stool, and hemolytic uremic syndrome. Okay? Now let me break it down for you. So this microorganism, look, this microorganism, when it infects intestine, okay, it causes inflammation of the intestinal wall and essentially small perforations in it, resulting in the blood going into the stool. Does that part make sense? But just as the blood can go into the stool, so can EHEC go into the bloodstream. We good? We already learned about hemolytic microorganisms. So this is the beta hemolytic microorganism, and when it ends up in the blood, it starts to break down red blood cells. We clear? So this is hemolytic component. Now, hemolysis leads to kidneys shutting down, and that results in accumulation of urea in the blood, failure of kidneys to excrete it. So we have hemolytic uremic syndrome. You may have heard about the outbreaks of EHEC associated with salad. Remember, there was some, like, basically every year. But first of all, the main source of EHEC outbreaks is food. That is correct. But the main food that's associated with EHEC is ground beef. And this is something, look, this is why microbiology is so interesting. So what is, from bacteriological standpoint, what is safer to eat? A steak or a burger? And then a steak. Because steak is the piece of muscle tissue, connective tissue, yeah. But the point is, the only place of a steak that legitimately is contaminated is its surface. Does that make sense? What's inside, it's fine. Okay, unless the cow had some massive bacteremia, which I doubt. Okay, so parasites is the different story, but as long as you kind of sear it on the surface, you kill everything on the surface, and then it's safe to eat. With the ground beef, you take meat and mix it. You mix the surface with the deep stuff. Does that make sense? So essentially distribute the surface microorganisms all the way through. See what I'm saying? And this is why, in case of steak being rare, that's okay. In case of ground beef being rare, it may not be that okay. Okay? Clear? Good? Now, continuing our enteric pathogen story, we're kind of going into the culmination of enteric pathogens. We're going to talk about Shigella, Salmonella, and Vibrio, and we're going to start with Shigella appropriately in brown color. It's a zoonotic infection that is transmitted usually via food, things like milk and poultry, results in dysentery and hemolytic uremic syndrome. Now look at this. This story and this story is two. They match, right? Is there anything in common between Shigella and EHEC? Turns out, yes. It is Shiga toxin, which inhibits translation. And when you stop protein synthesis, cells die, right? But it turns out that enterohemorrhagic E. coli stole Shiga toxin from Shigella. Does that make sense? This actually kind of harkens back to our conversations that we had when we were talking about genetics. Remember the horizontal gene transfer? So at one point in bacterial evolution, there was a horizontal gene transfer of Shiga toxin gene from some Shigella to some E. coli, which made E. coli enterohemorrhagic. Other than that, it's a typical E. coli. But it has this weird weapon that Shigella usually uses. Does that make sense? Clear? So another primary enteric pathogen is Salmonella. Salmonella has absolutely nightmarish taxonomy because a few years ago it was all changed. Taxonomists reclassified it, but people still used to it. So it creates a giant mess in the field of Salmonella taxonomy. So what it can do? Humble word enteritis. Okay, I don't know if anyone had salmonellosis. I had it once. It was mild. I had fever, and I thought that I will vomit all my insides out. It was absolutely terrifying. Okay, and it's treated with antibiotics fairly easily. Does that make sense? Now, in some cases, it can progress to so-called typhoid fever, okay, which is a severe systemic disease which can result in significant mortality, and it's a huge problem in the developing countries, especially in countries like India, Sri Lanka, and Bangladesh. Okay, does that make sense? Now, what's interesting about Salmonella is that it can be carried asymptomatically. Sorry, misspelled. Which can be illustrated first and foremost by the story of Typhoid Mary. Have you heard about it? Still, so poor woman, well, she was an asymptomatic carrier of Salmonella, typhoid fever, and she was working as a cook. It's probably the worst occupation for a person with that kind of asymptomatic carriage. And to make a long story short, she was eventually kind of imprisoned. I don't remember which island it was. Some quarantine facility in New York, and she was not allowed to work. Like, she was living in a pension, but it was kind of like a prison. Does that make sense? So, however, if you travel somewhere and you contract Salmonella and you carry out salmonellosis and you recover, you will still be shedding Salmonella for about 2 weeks after that. So just kind of, remember that. That makes sense? Now, in terms of culmination of enteric pathogens, we're going to talk about Vibrio cholerae, which is a really fun one. Well, we're going to talk actually about two Vibrios. One of them is Vibrio vulnificus. Wound infections. Can be contracted directly from brackish water or crustaceans. Okay, we good?
What's brackish?
Brackish, a kind of salty air. So not so much like seawater, but a little bit diluted seawater. Does that make sense or not? More or less? It's pretty common infection in surfers. Skin infection, right? So people surf, they fall, they scratch, they damage the skin. And then when I say crustaceans, I'm not talking about lobsters. I'm talking about microscopic ones. Does that make sense? So people would be in the same water with them, and then, infection of a wound, mortality rates of untreated Vibrio vulnificus can be as high as 50%. The wound infections are extremely, extremely dangerous. Okay, they rare, but dangerous.
Does that go with when you're scuba diving, they tell you don't touch the coral due to if you do get cut or scraped, a lot of the infections of that nature can happen?
Probably so. I never went scuba diving, but it's that is most likely. Vibrio, all members of Vibrio genus, they really like salt, and they prefer slightly basic alkaline environment, which is seawater, really. That makes sense? But most famous of them all actually is Vibrio cholerae, causative agent of cholera, profuse diarrhea. We good so far? Come. I'm going to tell you a story. We have some time, so I'm going to tell you a lot of fun stories about this one. So what does that mean, profuse diarrhea? Every 20 minutes, a bowel movement, like a good old bowel movement. People lose an enormous amount of fluid. Infectious dose, that's not for the exam, but infectious dose is very high. But the transmission is from water. So you don't drink 1 milliliter. Does that make sense? Like you drink a good, I don't know, half a quart of water, and you're going to get your infectious dose. Makes sense, right? Why don't we have cholera in the United States? The answer is simple: we have sanitation. So cholera is transmitted in the areas where there is no proper water treatment. Okay, people collect water, and when they face a choice between boiling water to kill all the pathogens, or use the same firewood to cook food, they choose food and drink water untreated. Does that make sense? And that results in the infections. Now, cholera is pretty common in Africa and India. Treatment actually includes antibiotics, sure, but the main thing is the IV line. If you can replenish electrolytes, people will often recover by themselves, as long as they can. People have to be hydrated in the hospital setting. It's impossible to do it at home, but if they can, it significantly increases the chances for recovery. Does that make sense? Now, an interesting thing is that Vibrio cholerae, the bacteria, they often hit your eye on those small crustaceans that I mentioned, like tiny little microscopic crustaceans. That makes sense? So one of the preventative strategies, and it's absolutely true, in India, the official recommendation is if you can't boil the water, you should filter it through 4 layers of sari cloth, which I believe is cotton. Okay? So 4 layers of cloth will contain substantial amount of crustaceans, reducing the amount of cholera that's in the water. And it's been shown to significantly reduce the risk of contracting this disease. Does that make sense? Now, what is the mechanism of diarrhea? So, toxin stimulates adenylate cyclase, which results in the increased cyclic AMP levels, which results in the increased ion excretion in the gut. And it's basic osmosis. So look what happens. Ions from gut epithelium, they go into the gut lumen, and they draw water with them, and this is why people develop watery diarrhea. Does that make sense? Now, here's an interesting story. It's just lovely. So cholera, lies at the beginning of modern epidemiology. It was very common in Europe, all right? And in 19th century, I can't tell you the year, but I don't remember if we talked about it, but it's kind of an interesting story. So in 19th century, there was an outbreak of cholera in London. And London physician, did we talk about it? John Snow? No? No, we didn't? Oh, London physician named John Snow. He was better than, that other John Snow who didn't know anything. He knew something. So he noticed that all cases of cholera were concentrated in like 2 blocks in London. That's it. So he started to investigate, and it turns out that all families whose members suffered from cholera were collecting water, drinking water, from the same pump. Like not the open well, but the pump well. You see what I'm saying? So he basically traced the outbreak to the single source of infection. But that was not the end of the story. Basically he demonstrated, look, cholera is transmitted by water. They all drank water from the same pump. People who drank water from a different pump did not have cholera. That's how epidemiology works. That's a beginning of modern epidemiology. But not only this. Turns out that cholera was affecting almost exclusively women and children. And men were fine. Do you have any idea why?
They were drinking beer.
That is correct. They did not drink water at all. Okay? That makes sense? It's fascinating how societal habits affect the disease transmission.